So the question says a force F on a particle with a mass 5 kg varies with time as shown in the figure. Now the reason I picked this question is most people have difficulty comprehending a graph and then relating that to a problem, because we're so used to having word problems that a graph sometimes throws us off. So this is our graph. This is a graph of force F, and it's acting t over t seconds. And let's say this is 1, 2, and 3 seconds, and this is 3 newtons in the force of the Newton. Right. So, and force says find the final velocity. Now, if I were to look at this and say there's force and there's time, where does velocity come in? The question is, once again, that we have a force and time versus time graph given, and we are expected to find the final velocity if the body starts from rest. So we know V naught is equal to 0, okay, and somehow if you were to relate the force and the time to the change in momentum of the system, we might be able to come up with the velocity, right? So the first thing we write is impulse, which is J, is equal to F times delta T, right? Is equal to delta P, change in the momentum. Now this is nothing but the area under this graph. So whenever you see a force versus time graph, always think of impulse. Now the impulse would give us the change in the momentum, which is mass times final velocity minus initial velocity. Okay. Now, having said that, so the area under this graph would be F times delta T delta P is the area under the graph, which is half times the base of the triangle, which is 3, times the altitude, which is also 3. This being the altitude. Okay? So this will give us 9 by 2. So 9 by 2 is equal to 5 times Vf minus 0. From here. We got that from there. Okay? Solving for Vf, we get final velocity is 0.9 meters per second. Once again, doing a recap, we've been given a force time graph, and we are being expected to find the final velocity of a body of mass 5 kilograms, which is starting from rest. So we write down that our initial velocity is 0, and then we say that our change in momentum would be, since the mass remains constant, it will be m times delta v. The change in momentum can then relate to the impulse, which in this case is nothing but the area under this graph, which is the area of the triangle, which is half times base times altitude, and then we get our final velocity is 0.9 meters per second.